Merry Christmas and welcome to the Festive Tech Calendar 2022. This session is about deploying Azure NetApp files using Terraform. This year, the Festive Tech Calendar team have chosen to raise money for the charity Missing People. We believe it's important to support charities who do great work. Without fundraising, the Missing People charity would not be able to help find vulnerable missing people and reunite them with their families. Please, if you can, donate to this very worthy cause. In this session, we are going to deploy Azure NetApp files using Terraform. As part of this, we're going to build a lab, which includes resources such as resource groups, virtual networks, subnets, virtual network peers, virtual machines, Azure Key Vault, and of course, Azure NetApp Files accounts, capacity pools, and volumes. To make this lab easy, I have already written the Terraform code, which can be found on my GitHub repo underneath Festive Tech Calendar 2022. If you browse to this URL, you will see at the top level there is a README file which contains details, overview, the prerequisites that you will require to deploy this lab, the resources that we are going to deploy, a high-level schematic of the deployment, as well as the steps you will need to carry out to complete this deployment. Once you have downloaded the Terraform code, browse to the directory where you save the code. Once in the directory, you're going to need to log into Azure. To log in, simply type AZ space login. This will fire up a browser and it will prompt you to select the user account that you wish to log in and your password. Once you've successfully logged in, you can then close your browser. Now that you are successfully logged in, it's important to check which Azure subscription you're working in. Some of you might have multiple subscriptions, and this is really important because you'll be deploying services into essentially what is your default subscription or the subscription that you have selected. To check this, type the command AZ account list -o table. This will present you with a list of subscriptions that you have access to as part of your account, and it will also highlight to you which subscription is your default. If you look at the last column where it says is default, you're looking for the one that says true. Now that we've successfully logged into Azure and checked that the subscription we are using is set as our default, let's have a look at the Terraform code. Here you will see I have a number of Terraform files. Now, the way I like to do this is I like to separate the individual resources into their own files. Some people do this differently. Now, I think if you talk to 10 different people, you might get 10 different answers. Ultimately, they all work. It's just personal preference as to how you do this. So here I have my main file. In my main file, I'm simply declaring the resource providers that I need to use as part of my Terraform deployment. As you can see here, I have Azure RM, and I've also got a random provider. This, as you'll see, is used to generate a random character string to make the resources unique. Next, we have our resource groups file. So within this file, we are asking Terraform to go off and create a resource groups. Now, the way the lab is structured, there are two individual regions, region 1 and region 2, and this is a trend throughout the whole of the lab. Resources are structured into numbers 1 and 2 to make it simple, and hopefully you'll go to see as part of the deployment where I use a terraform.tfvars file to declare the variables, then you'll see how this was laid out. So within the resource groups, as you can see here, I'm quite simply naming the resource group, telling it the location I would like to place it into. I'm also including tags. Tags are extremely important in Azure. Tag everything. It's so important. And as you can see, there are 2 resource groups being built here. Next, I'm going to have a look at my virtual network file. So within here, again, I'm creating 2 virtual networks, VNet 1 and VNet 2. And as you see here, like the resource provider group file, they are being named. I'm specifying the location. Also within here, I'm giving it address, DNS servers, tags. As always, you tag everything. And indeed, there are 2 VNets. Within each VNet, I'm also creating 2 subnets. There is a point to this, and you'll see as we go on, but ultimately I have subnet 1 and subnet 2. As you'll see here within subnet 2, I'm using subnet delegation, and this is really important for the Azure NetApp Files service. You need to delegate a subnet within your VNet, and this is what brings the Azure NetApp Files service into your local network infrastructure within Azure. What I'm also doing is, because I have 2 regions, and as part of this lab, I would like to access Azure NetApp Files across the peers, which I'm creating here. So there's a VNet peer between VNets 1 and 2. Now, a few months ago, Microsoft released standard network features for Azure NetApp Files. Those standard network features implemented in a few new capabilities. Network security groups being one of those, user-defined routes, and also the ability to peer globally. What I've also created is a network security group file. Now this is really useful because ultimately Azure is public resources, and ultimately you wouldn't want those resources to be available publicly. So what this network security group does is it locks down the access to the virtual networks, and at the top here it is going away using this small line of code to capture my IP address. It's then using that capture to input my IP address into the network security group, allowing traffic on specified ports. And as you'll see in this case, I'm allowing remote desktop, and I'm also allowing SSH. Next, we have a key vault. As part of this lab, I'm using Azure Key Vault to store a secret that is to be used for the passwords for my virtual machines. And the great thing about this is it's secure. It doesn't pass the password in plain text, and to gain the secret password you simply need to log into the Azure portal, go to the secret, and then copy it, or indeed as you can show secret and it will show you the secret in plain text. What I'm also building to support this lab are 2 Linux virtual machines. Now within this file, as you can see, it's creating a public IP address for this virtual machine. As I said just now, the network security groups are allowing access from my IP, from where I'm sat here at home, into Azure. And as I said, also it's allowing remote desktop and SSH protocols inbound for this. It's also creating the network interface card for this virtual machine. And then it's going to actually create the virtual machine resource itself. Again, as you can see, everything here is being passed using a variable. Also, as I mentioned at the beginning, Azure RM was a provider, as was indeed this random string provider. Now this random string is really useful because it helps create a random string which you can append to the name of all of your resources, therefore making them unique. So some people hopefully might use this code in a lab, and they might have a buddy or a friend who's working together and they might also use that code. What this random string does, it prevents names being duplicated. So ultimately these names will be unique. Now, probably the most important part of this lab, Azure NetApp Files. So in the anf-cc Terraform file, you'll see here, I'm creating my Azure NetApp Files account. I'm telling it the resource group and the region it needs to reside in. What I also have here is an example of an Active Directory configuration should you need to use it. Now, this lab is going to build NFS volumes. We're not going to build SMB volumes. SMB volumes rely on Active Directory for authentication purposes, and some of you might not have Active Directory running. If you do, great, then please experiment with this, comment this out and adjust the values as you need them. However, for the purpose of this lab, I've commented this section out. It's also tagging these resources, as I've always said. It's creating two accounts. So accounts 1 and accounts 2. The next thing that we need to build are capacity pools. So the capacity pools are being built here again in capacity pools 1 and capacity pools 2. I'm simply giving the capacity pool name, telling the account which I wish it to reside in, and I'm also stipulating a region, the service level. Azure NetApp Files has 3 service levels, standard, premium and ultra, but this is a lab. This lab costs money, so let's err on the side of caution and use the cheaper version of Azure NetApp Files, which is the standard tier. And I'm also going to tell it the size I wish the capacity pool to be. Currently, Azure NetApp Files minimum entry point is 4 terabytes. So the smallest capacity pool you can build is 4 terabytes. Once I have my capacity pools built and ready to go, I then need to create my volumes. As I said previously, for this lab, we're going to create NFS volumes. Now, the volumes are being created here, quite simply giving them volume and name, specify the location, the resource group I wish them to reside in, as well as the account and the capacity pool. We then need to give the volume a path, stipulate the service level, in this case we've already mentioned it's going to be standard, and the subnet that you wish the volume to be placed into. As I also already mentioned, a month or so ago, Microsoft enhanced the Azure NetApp File service by bringing standard network features. This is a new parameter which you can configure. You can either choose basic or standard, but for the purpose of this lab, I'm going to use standard. I'm also going to state that I want this protocol to be NFS and indeed the volume size. And as you can see, most of the configuration here is being specified using variables. Now, let's have a look at the variables themselves. Now, in my variable file, I simply have these variables as blank placeholders, because what we're doing is we're going to use a terraform.tfvars file. So the tfvars file is the only file that you should need to edit to make this lab bespoke for yourselves. By simply editing these parameters, it will update all those variables as you need. So the only file that you need to edit to make this lab bespoke for yourself is the terraform.tfvars file. Now that we've talked through the Terraform code that we'll be using as part of this lab, let's go ahead and deploy it. First, make sure that you are in the directory that you downloaded the Terraform code into. Next, we need to run the command terraform init. This will initialize the directory and get the relevant Terraform registry modules required to deploy our code. So simply type the command terraform init. This will go away, it will initialize providers, and you're ready to go. Once you've done that, we simply need to run a plan. The plan looks at the code and it gives you a visualization of what Terraform is going to go and deploy for you. To do this, simply run the command terraform plan. Terraform is now inspecting your code. It's going to run away and build this plan. And the great thing about this, Terraform does give you really intuitive error messages. If something's not quite right, it will tell you what is wrong. It will also tell you where it was wrong and how to rectify that. The Terraform plan is now completed, and as you can see here, it's listing the resources that it is going to push into Azure for us. The ones with green pluses are essentially telling us this is what it's going to build. So let's go ahead and deploy our code. To do this, simply type terraform apply. The terraform apply is now going to run away. It's going to read the plan, and ultimately the next thing that you will be prompted for is a option: do you want to continue, yes or no? Obviously, if you want to continue, you have to type yes. You can, if you want, append the terraform apply command and add a --auto -approve. What that will do is it will suppress the request for this prompt to continue, yes or no. Obviously, I want to deploy my code, so I'm going to say yes. So that's it. Terraform is now going to start pushing my code into Azure. Now, depending on what mood Azure is in, this can take anywhere between 20 and 30 minutes. So let's fast forward and I'll see you on the other side. As you can see, Terraform has now successfully deployed our code into Azure. Like I mentioned previously, this can take 20 to 30 minutes to complete, so it's a great opportunity for you to make yourself a brew. Let's go into the Azure portal and have a look at what we've created. So as you can see, I have two resource groups. I'm going to go into my North European resource group. In here, you'll see the resources that have been created, the ANF resources, the resources to support my virtual machine, Azure Key Vault, virtual network. So next we need to mount our volumes on our host. To do this, I'm going to go to the virtual machine. I'm going to grab the IP address of that virtual machine. Next, I'm going to go to my terminal. And here I'm going to use SSH to connect to my Linux host. So quite simply type SSH. Now the username that I'm using for this lab is labadmin. That is a variable which you can configure as part of the TF-vars file. It's entirely up to you if you want to go and change that. But for the purpose of this, the username is labadmin. And then I'm going to say the IP address of the virtual machine that I want to connect to. Press return. It's going to prompt me that, do I trust this? Do I want to add this to my known host file? I'm going to say yes. Next, I need my password. Now, to do this, if you go to your Azure Key Vault, go to your secrets, choose the lab admin secret, click on the secret itself, and then down here you can simply copy the secret, or should you wish to view it, you can say show secret. I'm going to copy it. I'm going to go back to my terminal. I'm going to paste the password in, press return. And there you have it. I'm now connected to my Linux host running in Azure. Next, we need to make the volume. To do this, go to your Azure NetApp Files volume, and then select Mount Instructions down the left-hand side. Now the great thing here is Microsoft included instructions for you how to do this if you're not too familiar with the Linux interface. These first two, or the one here specifically to install the NFS common packages, I've already done that as part of the virtual machine creation using a VM extension file. So you don't actually need to do this. But what we are going to need to do is to create a directory. So simply copy that command, go back to your terminal, and then paste the command in. So what we've just done there is we've created a directory of the name vol NFS lab FTC22 North Europe blah blah blah. That's all very well and good. But next what we need to do is actually mount our volume into that directory. So go back to your Azure portal, copy the mount command, then go back to your terminal and paste the mount command, press return. And that's it. You've now successfully mounted your Azure NetApp Files NFS volume on your Linux host in Azure. Now, should you wish to go into that directory and start creating some files, you might have one issue. I'll probably show you that now. So if I try to cd into that directory, it's going to say I do not have permissions. To rectify this, simply run chmod 777 and then the directory name. And if you try then to change directory, it will allow you. Also, if you try to create a file within that directory, likewise, it will allow you to do that as well. So there you have it. You've now successfully deployed your Azure NetApp Files Lab using Terraform. You've logged into your Linux host via SSH, created a directory, and mounted your Azure NetApp Files NFS volume into that directory. Now, once you've finished with your lab, it's really important to actually rip down all of those Azure resources because, hey, Azure costs us money. So to do this, it's quite straightforward. Go back to your VS Code terminal and simply type the command terraform destroy. This will go off, it will read the tf-state file, and it will rip down the resources that it's pushed into Azure for you. It's important though, if you have made any adjustments, any amendments, any additions to your resources in Azure, Terraform won't know about those. It only knows about the resources originally deployed. So if you've done any manual adjustments, you will have to remove them yourself. However, if you haven't, great. Simply run the terraform destroy command and that will remove those resources for you. This can take 5 or 10 minutes to complete as well. So now I've run the terraform destroy. It's going to go away, it's going to read the tf-state file, it's going to start to assess everything, and it will also, like the apply command, prompt, do you want to continue, yes or no? You then simply type yes, and Terraform will continue to remove all of the resources that it has deployed into Azure for you. As you can see, the destroy command has run through, it's ready to go. If you actually scroll through, it will show you all of the resources that Terraform is going to remove, marked with a red minus. So to continue, simply type yes, press return. Terraform will now go off and it will destroy all of those resources, and hopefully you can save yourselves a bit of money. If you, however, wanted to suppress the prompt for yes, you can. Like with the Terraform apply command, append --auto-approve, and that will just continue all the way through and start to destroy resources for you. This could take between 5 and 10 minutes. I hope this has been useful for you. Again, please do, if you can, support the Missing People charity. It is the chosen charity for this year's Festive Tech Calendar. As I said, I do hope this short video has been useful to you in understanding Terraform and how you can use it to deploy Azure NetApp Files to build yourself a lab. And I hope you have a very Merry Christmas and a Happy New Year.